So now I would like to explain a little bit about what my code actually does. So I used facial landmarks from MediaPipe. I can share my screen. So, so this is one example image. So if you put a look at the left eye of this image, you get to see 0.385386. It's a little too crowded. I used another image which had like much clearer numbering, and so I used these coordinates to calculate mainly two things. One is the EAR and the second one is the MAR. So the EAR is nothing but the eye aspect ratio and the MAR is the mouth aspect ratio. So the EAR was used for used in the logic to count the number of blinks and the blink duration, and the MAR was used for counting the yawns. Um, so this is the formula for EAR. So you got like P2 minus P6, P3 minus P5, P, and you calculate the delta, the absolute, and then you over two times the difference between the absolute difference between P1 and P4. Um, so you get a one value, and then you count a blink when the value is less than 0.28, for instance, right? So using the EAR value, you detect the blink the blink count, or you increase the blink count by using logic that can be described using finite state machines. So for instance, here's the blink FSM. And for instance, if the eye is already open, you would use some logic to detect the EAR. And if it's like less than 0.28, for instance, you would change the state from open to close and vice versa. And the same thing goes for the MAR, or the mouth aspect ratio. So this is the formula for MAR. You have average vertical lip distance divided by lip width, and when the MAR is greater than a certain threshold, that's when you calculate a yawn. And this is like a very fundamental um, principle when it comes to finite state machines, and among other things. And then based on ER and MAR, that's how you calculate the blink frequency, the average blink duration, and the yawn frequency. So I can quickly show you these being calculated within the code. For instance, over here you have the LID, the IDs that corresponds to the facial landmarks of the left eye and then the right eye, for instance. And then if you were to go to the FSM, for the blink FSM, this is how it's being calculated. This is the FSM logic. So it checks for the current state, and then that's how it this particular piece calculates the counts. And the same thing goes towards the yawn. So this just detects the state of the eyes and the mouth. So at this part of the code, you have like an EAR helper function that takes in the P1, P2, P3, P4, P5, and P6 coordinates, and then it gives you the formula, basically, the AR value, and based on the AR value is how you would change the states or calculate the blink. And over here, for instance, you have the eyes, and then you just use this formula, and then you see if it's less than 0.28, and that's how you you change the uh, counter based on the current state of the ice. And similarly, that's how the yawn is calculated. And you have like other metrics too based on the EAR and the MAR that's being calculated. And overall, this is a very simple video. Sorry, this is a very simple program or a project. It's a single page React project. And in this section, you get to see the YouTube link. And I passed in the YouTube video ID of the stimuli, which is nothing but the ID for the Coldplay Strawberry Swing music video. And there was another functionality that I was very much interested in, that is being able to automatically screen record and send in data to a third-party cloud storage. So I was planning on using Cloudinary. Mm, It isn't in this version of my code because this one's currently being fetched from main. But in the other development branch, I've been working on it, but fortunately I couldn't implement it due to a lack of time and some errors that I was facing. And that is why I've had to record myself performing the experiment. And due to lack of test participants, I am currently still waiting on people to do the test and submit their videos. So, and once I was done with this app, I pushed it to GitHub, and I connected my repository to Vercel. And I also had a domain name with me, and I used that domain name to point over to the Vercel deployment. Quickly. So I have it over here on my system. All right, thank you.